Hello, so today we are going to do this Leetcode problem, convert BST to greater tree. This is a part of Leetcode April daily challenge, so yeah, let's get started. So the problem says we get a root of a binary search tree and we want to convert it to a greater tree such that every key of the original BST is changed to the original key plus the sum of all keys greater than the original key. So for each node, basically we want to add on the sum of all of the keys that are greater than it. So sounds like for each node we will need to just add the right side, the sum of the nodes on the right side. As a reminder, a binary search tree is a tree that satisfies these constraints. Left subtree of a node contains all. Okay, so yeah, this is the. So we want to add the right side, it seems. So let's see an example here. Oh no, not the right subtree, because for example here for 0 we want to add the sum basically of everything, right? But one thing maybe we can notice here is that we can start from, if we, the far right it's just the value itself, and then 7 is 15 plus 8, and then 6 is 15 plus 6, which is 21. 5 is everything up to, so maybe we can do a traversal that starts from the right side. I think this would be a traversal somewhat similar to pre-order, but more with the right side first. So right side, then the node, then the okay, so traversal with right first, and then just add the sum. So maybe I could do, so first I'll just do helper here with a node that will call here with root, and we want to visit the right side first, then the visit node, then we want to do left here. Okay, and if not node, we want to return something. Okay, so now how do we get the sum back? We can have it returned, right? So here, if not node, we can have it return 0, right? And then here just return the sum, and so node that value is going to be plus s. Okay, and what should we return then? Should return node that val, I think. Would this work? Okay, seems like it doesn't at all. Okay, let me take a simpler one, so maybe just tree like this, or if they have this one. Okay, so that one looks like it works. Okay, what if I do one here or two? or maybe 2 here. So 0, 1, okay, let's do 2 here. And then here maybe 0. Okay, let's run this. Oh, okay, this needs to be 3. Maybe we can have 1 here. Okay. Okay, we need 3 here for it to work. Okay. So this is a BST. And so we should have had 3 traversed first. So let's print and see what we get here. Okay, so maybe we can check the order of the traversals we have here and just see what we get. And then here we can do okay. So we definitely go to the, if we take a look at our test case here, it's 3 to the right. Okay, so we should go to 3 here. We do go to 3, so that's good. And then we reach the end, so we get back with 0, and then we reach 3, so we get back with 3. We should replace 2 with 5. Okay, let's see if that happens. If we do replace 3 with 5, so the other thing I want to do, just to make this easier to see, okay, so if we go back here, see our tree, look at our result. So before was 3 and then 3 that didn't change, that works. And then 5, it did change, cool. And then now we go to the left side 0, right? Okay, and then we go to the left side again. Okay, that's where the problem is, I think, because before going to the left side here, so we go to the right side, sorry, so that makes sense. And then we have 1. Okay, yeah, that's the problem. We need the entire sum. So what I'm going to do instead is have something like this. Okay, and then we need to add to this. Okay. And now we need to add this every time. Okay, we have a problem here. Okay, just indentation. Okay. Okay, 2 gets assigned, and then we come to 0. We come to 1 first, and so we add from right. S is equal to 3 instead of. Okay, so that's a problem again. Every time we get past something, we want to override it. So it's going to be node.val plus that, and then we want to assign this. So we'll go to the right. Oh, okay, yeah, sorry. Okay. So we want to do 3. So this one would be 5 plus 1, so 6. That works. The problem is, and then we check the node again. We modify 0 with it should be just 6. Okay. Yeah, this here is not right. So maybe I think okay, what if we just do okay, let's see. Okay, so what I'm thinking I'm going to do instead of this is pass a sum so far value instead. And now I return that. And then let's get rid of this. I'll still do call helper on node.write first, right? And then the sum so far shouldn't change. And then we'll get write sum, okay? And now I'll do for the node value after getting the write sum, I'll add that in. That's what we are doing here. And then after that, I'll call it on the left side. Now on the left side, I just need to pass in node val because we changed it to include write sum. And that way we get left sum. And now since left sum contains both the write sum node value and the left side, we can just return that. And I think this should work. Okay, sum so far starts out as 0. Okay, submit. Okay, cool. So that passes. Yeah. Okay, so yeah, I wonder if I can solve it differently here with a different, maybe easier way. So I'm thinking maybe I can just put the elements in a list with an in-order traversal, and then pop from the end, and each time add the value. So what that would be here is this would be an in-order. Okay, let's actually start from scratch. So this would be an in-order traversal on a node, which would mean we will need to do node.left, and then this add the node. So maybe we could have values here, and then take the values and append node.val, and then here do something like in order node.write, okay? And if not node, just return. And now here we need to call it on the root. Then we can do the second part, which is popping off the elements. And so this would be update tree, or let's call it just update for now. And what we'll do there is we will say self.values, and we will pop the value from the first position, and that will give us so we want to assign current, and then we'll do current plus this, and then we will need to assign node.val current. So we pop the element, we give the node value that sum, and then we do update so what I'm trying to do is I have them in order here. I have left, right, and then I go from, so if I go open terminal here so that we can see, so if we have an array like this and do a pop 0, so that will pop the first element, right? So it will pop would have left and then value, so it would pop left first. Okay, what if we just pop? So if we do A and just pop. Okay, so maybe pop right first. We don't want to assign that to the root, do we? Yeah, I don't think we want to update the node right away. We want, I know we definitely want to pop first this, but we want to go all the way to the right so that we can reach 8. We also want our use case to do something here. And then we want to pop. But then we want a place where we collect the values. So I'll call this S. Okay. And then whatever we pop, we want to add it there. Called update root. And then we want node.value here to be assigned whatever is in that, and then we want to do update node.left. And then at the end here we want to return root. Okay, we want to return something here as well, which is just return. Okay, so that passes, but I'm not sure it's actually more clear. It doesn't seem like it is. I wonder if we do a suffix sum, which means basically let me try it. I'm not sure if it works. It will work, but okay. So can we do the suffix sum or whatever that is? So if I do this here, and let's get rid of this. So you could just do for I in range of. Okay, and then we can do self values at I. So we can just start from -2, and this is going to be plus 1. Okay, and now if we do this, we can say node.value is equal to that. Okay, I wonder if this would work. Does work. Interesting. That's awesome. Yeah, I think this one is a little bit more intuitive, just because we can interpret. This is exactly what we are doing. We want it to be, so this would be the sum of values greater. Yeah, because like, just to show you, if I print self.values here and then print. Okay, let me actually also make this more clear. So no update, call this update. Yeah. So this is the values, and then this is the we printed, and then we could do maybe suffix sum just to make this clear. Okay, and this is what we want to pass, and so I'll print here self.suffix sum. Okay, okay, cool. So looks like it didn't get updated. So here we want, of course, plus the element, right? You know what? Let's just keep it at self.values. Okay. So we have the array sorted order here because it's a binary search tree and we are traversing in order. And then we'll get 8, we'll sum 15, 21, 26. So we'll do the sums, like just the suffix sums, which is exactly what we want, right? Because each suffix sum is the sum of the value greater. So for example, 8 plus 7 is the sum of the values greater than 6. And then from there we can just recreate the our yeah, just update the values for our tree essentially. Yeah, I think this is nice, so let's just submit them. Cool. And from this you can deduce that, okay, if we used some no, that's not what I want to say. Okay, so we have this. I wonder if there is a way to make it even better. So one way maybe we can do this is instead of these values here, can I return just plus not that val plus and let this do the collection for me? I wonder if this will work. And then here we could just have okay, so that works. Okay, so from there, basically my goal here is to get rid of all of this dot self. So if we do this, get rid of this here, get rid of this, get rid of this, and just pass values. And of course, I position and have values here, and that way here we do this, and here I will start out as the last value, right? So like the value is -1, and then here we want to pass I. Yeah, the problem there is that it won't be modified. We would have to have self, otherwise it won't be modified. Yeah. Yeah, I don't think it's worth it, because what I was thinking is, okay, either we return values or we return I from the update function, but that's not nice either. So yeah, I think we should go back to self.values here. Okay. And this would be self.values. Okay, so now for this piece here, I think we can do node and. Does it work? Okay. Okay. Yeah, I think this is good enough. Cool.